Good morning, my dear students. Today I am going to explain one question from physics in electricity. The question is a cell of EMF, that is electromotive force, 2.5 volt, and internal resistance, that is IR in short, 1.5 ohm, is connected to two resistors of 6.0 ohm and 30.0 ohm in series as shown in the figure. This is the figure. This is the first resistor 6.0 ohm. This is second resistor 30.0 ohm. Here internal resistance is 1.5 ohm and this is electromotive force which is symbolized as 2.5 V, that is volt. Now we have to calculate the potential difference first. Second, that means potential difference shortens at PD across the 6.0 ohm resistor. Second, voltage drop when the current is flowing. And third, potential difference PD across the cell. So you have to keep in mind that here you find all in these cases that you have to find. Without current we cannot find PD across the cell. Okay. So voltage drop. In every cases current is needed. So the first motto of ours is to find current. That is I. Now the solution is EMF of the cell, that is electromotive force of the cell, equals to 2.5 volt. And you have always to keep in mind, if you are writing volt in full, then V should be in small letters. And in short, if you are writing volt, then V should be in capital letters. So, electromotive force of the cell is 2.5 volt and that is written as, symbolized as capital E. Internal resistance IR is 1.5 ohm. So, that is symbolized as small r. External resistance is equals to R1 plus R2 as they are in series combination. These two resistances are in series combination. Okay, and why it is in series combinations? Because one end, that is positive of one resistor, is attached with negative of another resistor. Okay, so this is in series combination. Now current is equals to I equals to electromotive force by internal resistance plus external resistance. That is I equals to capital E by small r plus capital R. So this external resistance is total resistance, that is capital R. We have got R1 plus R2. So 6 plus 30, that is 36 ohm we have got. So capital E, which is electromotive force, that is 2.5. Internal resistances plus external resistance, that is small r plus capital R, is 1.5 plus 36. So that is equals to 2.5 by 37.5. After decimal you find there is one digit in the numerator and denominator. That's why we remove the decimal, no need of putting 10. Okay, and so we get 25 by 375. And then we cancel it, 25 15 ja. Yes, 25 15 ja. 375, that's why it is equals to 1 by 15. So after bringing in decimal we get 0.06666. 6 is coming repeatedly just like rings decimals. So it is a non-terminating recurring. Yeah, non-terminating decimal. That's why we write 7. Yeah, so 0.07 ampere. This is our current. And for ampere, capital A we will write, and when you are writing in full, it should be written with a small a. Never start with capital A. And when you are writing only A, then it should be in capital, not in small. Okay. Now potential difference across 6 ohm resistor is equals to 6, that means R1 into current. R1 stands for the PD through which we are finding the resistor through which we are finding the PD. So that is R1, and R1 value is 6, and current we have got 1 by 15. So 6 into 1 by 15, that is equals to 2 by 5, and that is equals to 0.5 volt, or equals to 0.4. It is 0.4 volt, that is equals to 0.4 capital V. Here also you have to keep in mind, if you are writing volt in full, then here should be written with small letters, otherwise V should be in capital letters. Now voltage drop, that is equals to current into internal resistance. How much current we have got, if that is multiplied by internal resistance, we will get the voltage drop. So current we have got 1 by 15. Internal resistance we have been given 1.5. So decimal we are removing, and then we get 15 into 1 by 15 into 10. 15 cancels, so 1 by 10, that is equals to 0.1 volt, or equals to 0.1 capital V. Now potential difference across the cell, that is equals to external resistance into current. External resistance, what does this mean? This means that there are two resistors. So the equivalent resistance of those two resistors is capital R, and that we have got 36. Current, that is I, that is 1 by 15. So potential difference across the cell equals to external resistance into current. So capital R into I, that is 36 into 1 by 15, is equals to, both are divisible by 3. So 12 3 is 36, 5 3 is 15. So 12 by 5 you got. And that is equals to 2.4 volt. Thank you. If you like, please share and subscribe.